Okay, so here we have a situation where a county has some money set aside for salaries for students in a summer's job, in a jobs program for the summer. So these students would decide whether or not they wanted to, apply for a job if you wanted a summer job, right? So the people in charge have to think about a bunch of things, and just to name a few, the number of students they have to think about that would be interested in the job. Some students don't want summer jobs. Others have full-time jobs. They don't need a summer job. They need to think about the relationship between the amount of pay that they offer each student, um, and the number of students that are going to be applying, and then the actual number of students that they could actually hire. Okay, so these are just a few of the things. There's other things, but these are the things that we're going to think about for right now. So if they had whatever, they just start out thinking about, okay, so what if we paid a student 500? We would expect about $500, and this is for 8 weeks. Let me write this down so that 8 weeks of work. Okay, for the whole summer, for July, August, June, July, whatever. But for 8 weeks of work, we're going to pay each student $500. And we're going to expect, well, if we pay them 500, there'll probably be about 55 kids that apply. Now, if we up that pay, obviously we're going to get more students. And the more we raise the pay, the more students, or the more, people that would be interested. And these are students, so they're students. So does this pattern seem reasonable to you? That the more you offer, the more money, the more students that are going to be interested. Well, yeah, that seems pretty reasonable. If you offered me more money and I told my friends that instead of $500 we're going to be getting 2,000, I think that, more people would be applying. Now, the next thing that we're going to do is using this information, all right, and this is going to be our x coordinate, this is going to be our y coordinate. We're going to find a function, and then we're going to sketch this graph. And we've done this before. So this is old news for you guys, but here's how we're going to do it. So in finding the function, if you remember, if we have a bunch of points, what we can do is, first thing we're going to do is we're going to find the slope. And remember, the slope is the change in the change in y divided by the change in x. So I just chose 2 points, and what I did was I chose this point and this point, and then I found my slope. So 210 minus 55 divided by 2,000 minus 500 is 0.1. So now we're going to choose a point, and we're going to choose a point from our bunch of points here, and I chose this one. Okay, and the reason that I chose this one is because it looked to be a little bit easier than the 55 and the 110s. I always try and make it easy on myself. And so remember our formula, y minus y1 is equal to the slope x minus x1, where x1, y1 is our point, and our m is our slope. Okay, and then we'll do some algebra. So here's our y value, here's our x value, and we substitute that in. The first thing I did was I did my distribution. So 0.1x minus 100. Then I added the 100 to both sides, and this is my function right here. So this is what I'm going to graph, okay? And there we go. So we found our function. And the next thing we're going to do is we're going to sketch our graph. And here's our graph. Remember that the x value is the amount of money paid, or the amount that you're going to pay. You can't hardly see that. The pay that the students will be receiving, and this over here is the number of students. And it makes sense. The more pay, the more number of students that we're going to get. Okay, so number of students that could be higher and the number of students interested, it all depends on the amount of pay. So what we're going to think about is that if this county has $200,000 set aside, we want to um, find out, we're going to write equations, all right, that match some of this information that I'm going to talk about. So for what pay rate will the number of students who can be hired equal the number of students who would be interested in work? So this is what we know, that the number of students interested in work, right, the equation that we just found was y is equal to 0.1x, and the amount of pay that we have is 200,000, and dividing by the number of the amount of pay, right? This x is, remember, x is equal to pay. Okay, so dividing by the amount that we're going to pay is, we're going to find about how many students we can hire. Does that make sense? I hope it does. Okay, so all we're going to do is, what we want to do is we want to find the pay rate and the number of that will attract. All right, let me start again. What we want to do is we want to find what pay rate will the number of students who can be hired equal to the number of students who would be interested. All right, so this is what we have. We want to know where our x's are going to intersect so that we get the correct amount of students, our y value, and so that we have the correct amount of money. Okay? I mean, we don't overextend ourselves so that we don't have the right amount of money. Okay, so here's our graph, and it makes sense. This was our graph from before. Whoa, sorry. Together. This was our graph from before, and this is where y is equal to 0.1x. This graph right here is the $200,000 divided by x. And remember that, again, over here, let me change my color, maybe that'll help here. This is x and this is y, and this is pay, and this is number of students who are going to apply. Okay, this is 1,000, 2,000, 3,000, and 4,000. And it makes sense, if you're going to offer a student $4,000 for the summer to work, there's going to be a lot of students that are applying, and this goes up by 50, so this is 50, this is 100, 150, 200, 250, 300, 350, 400, and up here is 450. So our intersecting point looks to be, not very straight lines, about there. So if I were to do this 0.1x is equal to 2,000 divided by x, I would find that the amount of pay, the optimal amount of pay to offer students is about $1,414 for the 8 weeks of work. Okay, you can find this if you graph these two graphs in Desmos. You can find that intersecting point. Usually if you graph it on a TI 84 or 83 or whatever is at the labs, you can get the same intersecting point. All right, so it says, so the next question would be, let me just, okay, well, we'll just do this one. Okay, I'm going to look at the same graph here, is for what pay. Okay, so now what we're going to look at is for what amount of pay will the number of students who can be hired be less than the number of students who would be interested in working. So really, at this point, what we're looking at, here we go, is like the information down here. So what is this point like right before there? And that's what where we would have the number of students is actually going to be less than the amount of pay, right? It's an inequality, right? It's not less than or equal to, but it's an inequality. And then up here is where would we have students, more students applying than we could actually pay. Okay, and that means that we don't have that much money. If we hired that many students, we would run low on money. Okay, so these are just inequalities. This is just a little bit of an extension for the whole thing. The whole idea for this first lesson is just to see if you can figure out, how much pay you would actually give to a person. If you only had $100 and you wanted to split it up between your friends and you had 6 friends, how much money can you give each one of them? Okay, this is the kind of thing that this is looking at. County has X amount of money. They want to give it to students. Well, make them work for it, but give it to these students. And they want to know how many students they can actually give this money to. All right. And that is what you're going to be doing. There's only like 4 or 5 questions. So have fun.